And in this case, if we wanted to find the greatest common divisor of 310 and 710, we would use the Euclidean algorithm to generate these successive equations that you see on the screen here. If you'd like to watch that video and learn where these equations came from, click on the link you see on the screen. Notice that I've colored in the dividend, the divisor, and the remainder in each of these equations. Remember when we talked about the division algorithm that those are the numbers that get copied to the left as we go through each equation. Notice that in the first equation we have a remainder of 90, and then that remainder becomes the divisor, and then that divisor becomes the dividend. So that's the same 90 each time, and so the color coding is going to help us as we work through Bézou's identity. So what is Bézou's identity? Well, notice at the top of the screen now the problem has changed. Now we want to find integers u and v such that u times 310 plus v times 710 equals the GCD. And those are the coefficients that are guaranteed to exist by Bézou's identity. So Bézou's identity says that we will always be able to find numbers like that. If I replaced 310 and 710 with two completely different numbers, I would still be able to find integers u and v such that u times the first number plus v times the second number equals the GCD of those two numbers. And the way that I do that is by starting with the equations that I get from finding the GCD in the first place. So these four equations that you see on the side of the screen here, we need to do that anyway. So even if you knew what the GCD was, we would still need these equations, as you'll see in a second. Okay, so we know our GCD is 10. And what we'd like is an equation that looks like 10 equals u times 310 plus v times 710. Well, we can't get that right away. But what we can get easily is an equation that looks like 10 equals something times 40 plus something times 90. And we can get that from this next to last equation. So if I solve that equation for the 10, which I'm just going to do by subtracting 2 times 40 from both sides, I'm going to get the equation 90 minus 2 times 40. But I'm going to rewrite that slightly just to make it